So y'all had classwork on Friday, and I'm going to look over that. I haven't quite had time yet, but I will. And so today we're going to talk about solving polynomials. Equations. Now, you're going to see that the process of doing this is almost identical to when we solved quadratic equations. The difference is what we're factoring now as opposed to what we were factoring before. So now what I'm going to do is make sure, I'm going to make my equation equal 0, make sure everything's on the same side. And then I'm going to start going through my process of solving. And whenever I solve, remember this one, I take each parenthesis and set it equal to 0 to solve. So this one goes to 0, this one goes to 0, everybody goes to 0, and then I try to solve. The difference now in the polynomial equations versus the quadratic equations is if you think back to how I've been factoring, sometimes I have quadratics even whenever I factor. So it could be that this is linear, and it could be that this is a quadratic. So I'm going to have to go back to the very first unit and remember how to solve a quadratic equal to 0. Okay, and those are the things like I tried to factor and solve that one. I can complete the square. I can use the quadratic formula. All those things are different ways we talked about solving quadratic, so we're going to have to remember all that. So there are a few notes on here. The first bullet says for quadratic equations solved by square roots, completing the square, or the quadratic formula. That's what we just talked about. And remember, coming into play also will be our complex numbers and our irrational numbers and things like that. So that means irrational meaning our square roots. We'll need to break those apart, make sure our answers are simplified. Are y'all ready? All right, we're going to run through a few of these, and then the rest of them are going to be left for you. So we'll start with number 1. Number 1 is x to the third plus x equals 0. What am I going to do in order to solve that? Because it already equals 0. Factor. How do you factor? Well, I can't use quadratic anything because it's a cube. So this is the difference here. See, this is a polynomial and not a quadratic. Does everybody see that? So as we factor polynomials, if this wasn't here and I said factor it, what would you do first? Well, but x is not a perfect cube. X cubed is, but x is not. Take out an x. That's exactly right. I would take out an x. Remember, your first step in factoring always, always, always is to look for that GCF. So I'm going to take out an x first. And what's left when you take out an x? Plus 1. Can you factor this any further? Obviously, x you can't, but how about this one? All right, look at your orange sheet. 2 terms. Is it a difference of squares, a sum of cubes, or a difference of cubes? None of them. It's none of them. Because remember, in order to do a difference of squares, it has to be what? What's difference mean? A minus in the middle. If it's not a minus in the middle, it doesn't work. Now, if that was cubes, it would. But here it wouldn't. So I cannot factor any further. So once I'm to the point where I cannot factor any further, I go ahead and set everybody to 0. Okay? So I have x equals 0. By the way, how many answers should I get to this? How many answers should I get to the whole equation? Look at the whole equation to begin with. Why? Because the degree is 3. So I should get 3 answers. Okay? Even if some of them are repeated, which is that multiplicity effect, right? I should still get 3 answers. All right, so if I say x squared plus 1 equals 0, this is definitely a quadratic. With x in it only one time, how do I solve it? You move it. You solve it exactly. You SAD map. Remember, if you only see one x, the hardest part of this section is going to be you recalling how to solve quadratic equations. Okay. This I can SAD map because x is only in here one time. So subtract the 1. Now what? Square root. What's the square root of -1? What? I. That's exactly right. But not just I, plus or minus I. That's a good job. That's 2 solutions plus the 1 here gives me the 3 solutions I was looking for. 2 imaginary and 1 real. Bringing back the i's. Plus or minus I, so positive I, negative I, and 0. Oh, let's do number 2. Three. So 0, positive I, and negative I. So there's your 3. All right, let's look at number 2. As you do these, make sure you factor completely where you can. Directions simply say to solve, what shall I do? Move the 3x squared. That's exactly what I would do also. So once I move, because my first step, of course, is to make it equal 0, but the second step, that's where I'm going to start factoring. So I have 4x cubed minus what? There you go, 10x squared. It equals 0. Tell me what to do now. 2x squared this time. What's it leave? Close. You took 2. 2x. I should get how many solutions? 2, right? 2? 3. 3. All right, look at this 2x squared. If I set that equal to 0, what does x equal? What is its multiplicity? 2. Why? There's 2 of them. That's exactly right. It's 2 times x, so this one goes to 0, this one goes to 0. So this is 0 with multiplicity of 2, which means what on the graph? It bounces. It bounces at 0. Good job. So here's one answer, but technically it counts for 2 answers because it's got multiplicity 2, right? So there's 2. And then 2x minus 5 equals 0. What does x equal? 5 over 2. That's exactly right. So 0 with multiplicity 2 plus my 5 over 2 gives me my 3 solutions. I bounce at 0 and I go through at 5 over 2. Easy so far? It's all right. Yeah. Let's go through number 3. X to the 4th minus 64 equals 0. What the heck? They're both perfect squares. You're exactly right. Difference of 2 squares. What's the square root of x to the 4th? What's the square root of 64? Can I do anything else there factoring wise? No, 8's not a perfect square, right? If that had been a perfect square, I might could split them up one more time, but since it's not, I'm done factoring, so I have to set each factor equal to 0. So if x squared minus 8 equals 0, wait till y'all see what you have to get. See if you remember. I should get how many answers? 4. The degree is 4 here. Look at the first one. What should I do? Okay. Now what? Okay. What's the square root of 8? Ah, you remember. Because this has got a perfect square in it, I have to say, right? So x is actually, and don't forget the plus or minus, because the plus or minus gives me the two solutions I'm looking for. Plus or minus 2 root 2. Y'all remember doing that? When we split, yeah. Everything comes back in here. Nothing ever goes away for sure. Is anybody confused? Yeah. Well, now you go, I was complaining then and it really wasn't that bad. Now it's, all right, I still got another piece to solve. You're exactly right. So for this one, when I go through, I've got that negative under there. That's the only difference. So it's going to look the same here, except it's going to have an I on it because it's negative under that radical. So that's 4 answers right. 2 imaginary and 2 real. 4 is pretty easy. Let's crank it up a little bit. Ooh, let's look at number 5. Yay! Y'all be excited about 5. Some of these you are going to spend longer on than others. How many solutions should I get to this equation and why? Why? Degree is 3. This looks like an easy problem, right? You look at this and go, oh, that's nothing. But then you go, wait, I need to factor it. How does that factor? Little parenthesis, big parenthesis. It's the cube, right? Go ahead and fill in your signs. Same, change, plus. What goes in the first set? X plus 5. Fill in the second. What does it look like? Ooh, I'm ready to solve, right? So this is easy. No problem, right? What in the world am I going to do with this? Can you factor it? Does anything multiply to 25 but add to negative 5? Hold on. In fact, they'll give you a hint. Anytime you have a sum or difference of 2 cubes, this is never going to factor for you. Okay. So if I have a quadratic that equals 0 that cannot be factored, how do I solve it? I could use quadratic formula. I could use completing the square. I'm going to use quadratic formula for this one because y'all love quadratic formula with your videos and everything that you did. If you don't remember, tell me what the quadratic formula is. Opposite B So if you don't remember quadratic formula, brush up on that because it's back. So here, A is 1, B is -5, and C is 25. And so I'm just going to plug in this quadratic formula. Opposite B plus or minus the square root of B squared minus 4 times A times C all over 2A. 25 minus 100. You might see what's fixing to happen. Imaginary. You're exactly right. Because 25 minus 100 is negative 75. And I know I'm going a little bit fast through this because this is the last section, or this is very beginning. How's that break up? That's right. 25 and 3. So this is 5 plus or minus. Now notice I got the negative, which means what? 5i root 3 over 2. How many answers is that? 2. If you ever see a plus or minus, that's 2. I got my 3 answers. One of them was pretty nasty to come to. Not terrible? That's the worst part of it, is when you have to use quadratic formula because you don't have any other choice. 3, up, negative 5, I lied. What do you mean? So once it's factored completely, you have to set each factor to 0. So once I got to this point, I know I can't factor that anymore, and I know I can't factor that anymore. How do I know what? Oh, did you get an orange sheet? Okay. That's a special pattern, so that's the only difference of 2 cubes. Yeah, that's why you're confused. That's a new pattern. And I'll have to actually get you those. I thought I have one up there, but I must not. I'll run you one with the patterns on there. All right. Let's look at number 9. It already equals 0, so half my work's done for me. Not half, maybe a third, maybe a quarter. Maybe not even that much, who knows. All right, tell me what to do. So how do you know you can do that? Look at y'all. Even, half, constant. Okay, leading coefficient is 1, so that makes for my shortcut factoring, right? Which means that's super easy for me. What multiplies to negative 42 but adds to 1? 6 and 7, which one needs to be negative? I heard 6 and I heard 7. 6. It's positive 1x squared is what it's got to add to. So I'm going to do x squared minus 6, x squared plus 7 equals 0. If you still want to group it, by all means, group it. Slash it and go through, but you can use the shortcut here since there's a leading coefficient of 1. Can I factor either one of those any further, and how do you know? No, I can't, because these are perfect squares. That's not. These are not perfect cubes, and that's the only option for 2 terms, right? Squares or cubes. So I'm ready to set it equal to 0. So if x squared minus 6 equals 0, x squared plus 7 equals 0. So on the left side, I'm going to go ahead and add. Now what? That's right, square root. What's the square root of 6? Trick question, it's the square root of 6, right? So this is actually, don't forget the plus or minus, the square root of 6. Why am I not breaking it up? Because you can't. Why can't you? It's not divisible by a perfect square, right? Does everybody see that? Why I broke up one and I didn't break up the other? All right, how about the next one? Close. Plus or minus I root 7. That's exactly right. There's two solutions, which gives me my 4 that I was looking for. What do you think? It's all right. Let's do number 14. I want to finish in time because you've got a little more work today than what I normally give you, because I really don't want to spend more than one day on this. So my thought was up through 16 classwork, and we'll work through some of those. You should be able to get done. And then through 12 would be your homework for tonight on the second page. Some of them are super duper quick and it'll take you like 30 seconds. Some of them will take you a little bit longer, but you don't have a whole lot of quadratic formula ones. All right, this one looked the worst. That's why I picked it. It's really not that bad, but what do? Move everything. It's got to equal 0 before you start, okay? Good rule of thumb is make sure your leading coefficient stays positive. Okay, so wherever your leading coefficient, wherever your degree term is, make sure that one stays positive. In this case, it's what? 5, and it is positive, so that means I'm going to take all of these and move to this side, okay? So that 5 stays positive. It'll make my life a little easier as I go. So I'm going to subtract x squared, and I'm going to subtract 1. 5x to the 4th plus 12x squared minus 9 equals 0. What now? Factor it. Even, half, constant. Can I shortcut this one? No, why? That's not a 1, that's a 5, which means, I have to group it together, right? What multiplies to negative 45x to the 4th, but adds to 12x squared? Oh, you got that quicker than I did. 15x squared negative 3x squared, right? It's got to add to positive 12. So that's how you determine which one's positive and which one's negative. I am going to do the negative term first before I group because it'll make it a little bit easier for me. What can you take out of those first two? X squared. What's left? Exactly right. Middle sign stays. How about the last two? 3. That's exactly right. What's left? Same thing. And if I've done it correctly, it should be the same thing, right? Right. I now have 5x squared minus 3 times x squared plus 3. What now? Everybody goes to 0. That's exactly right. We'll take the first one, on the one on the left first. What do I do? Add the 3. Should I square root now? No, divide 5 first. That's exactly right. Ooh, this is going to be fun. Tell me what to do. Can I leave it like that? It would be nice. What's wrong with that? What's wrong with the way it is? Do y'all remember? What's wrong with that? I can't have a radical in the bottom. How do I get rid of it? Close. You're really close. You multiply the top and the bottom by what's in the bottom. The top becomes what? That's right. The square root of 15. What does the bottom become? What's this? 5. You're exactly right. You put them together, you get the square root of 25, and the square root of 25 is 5. That's what allows me to get rid of that radical in the bottom, and I throw that plus or minus in front. You cannot simplify this because that 5 is no longer under a radical, but remember all those rules. I can't believe y'all don't remember that in the conjugates we talked about. Remember those? And when we had a complex versus an imaginary in the bottom, if we multiplied by I or change the sign in the middle. All right, how about the one on the right here? Move the what? The 3? Same mirror board. That's exactly right. Plus or minus I times the square root of 3. So if you think about it, this whole section is the only new thing is making it equal 0. But this pulls a lot of information from everything we have done back all the way to Unit 1. Okay, because remember we started with quadratics that very first week, and that's right where this is pulling us back. Quadratics, radicals, all that good stuff that has to come back. What do you think? Do you need me to do another one, or are you ready to start on your own? Okay. You give me one that you think looks the hardest. 16? 15 or 16? It already equals 0. And I'm in a 4-term situation. I need to go ahead and slash it. That's exactly right. Remember your orange sheet if you get confused. If it's 2 terms, 3 terms, or 4 terms, what you need to do. Okay. So I am going to try to slash it and see if that works. It may or may not work. I may have to back up and plant and retry something. So what's the GCF of these first two? What's left? The middle sign stays, but if the middle sign is a subtraction sign, that one changes. What can I take out of 32x and 48? 16, that's exactly right. What's left? How do I know if it worked or not? That's exactly right. These are the same. So it worked. So go ahead and finish factoring. 2x minus 3. That's gone, so I have x squared minus 6. Can I factor any further? Good job. X squared minus 16 will break down. How does it factor? That's right. Once I have all linear factors, I cannot factor any further, and I am ready just to set to 0. So 2x minus 3 equals 0. X minus 4 equals 0. X plus 4 equals 0. These are easy solves because they're linear. I got 3 over 2, 4, and negative 4. How many was I supposed to get? 1, 2, 3. Y'all good? Anything else you see that looks confusing to you want me to do before I set you loose? 12? Okay. Oh, because it's 6. It already equals 0. How could I factor, or what do you see, what do you notice? I see a GCF also. I would definitely take out 2x squared. When you take out 2x squared, what's left? To the 4th minus 5x squared minus 24. Now what? 6 answers. That's exactly right. Bleh. Factor it because even, half, constant. What's the leading coefficient? Lucky us. We can shortcut it, right? What multiplies to negative 24 but adds to negative 5? Negative 8 and 5. I don't have to worry about the x squareds on them this time because I'm not going to. I'm sorry. I don't have to worry about the x squared because I'm not going to slash it this time. I'm just going to use my shortcut. So I have 2x squared times x squared minus 8 x squared. This looks a lot like one we just did. Can anything factor any further? No, these aren't right. 2 terms. They're not both cubes. The one that's got the minus in it's not perfect square. 8's not a perfect square, so I'm going to stop. 2x squared equals 0. Here's my repeated solution of 0, right? So that counts for 2. That's multiplicity of 2, but it counts for 2. X squared minus 8 equals 0. How do I solve that? Square root the 8. That's exactly right. But it's not square root 8. It is plus or minus, but you go. It's right. That's exactly right. We just did this one. This one's 4 and 2. So it's plus or minus 2 times the square root of 2. There's 2 answers. That 0 is technically 2 because it's got a multiplicity of 2. And how about this x squared plus 3? I times what? That's exactly right. Plus or minus I times the square root of 3. 2, 4, 5, 6 for the multiplicity. They're not bad. The worst ones are when you hit quadratic formula. That's the worst. But other than that, it shouldn't be that bad for you.